Welcome to 4 Keys Private Tuition. So let's continue with our exploration of MOSFET transistors. So in this particular video, we are going to look at some other key features of MOSFET transistors that you need to be aware of before you can start to fully utilize them in your project. So let's look at other features. So just a recap of what we talked about in the previous video. We said that you can use a transistor to switch on a voltage, a current between your gate and the source using a smaller voltage between your gate and the source. And we saw that as you continue to increase the voltage between your gate and source, you are going to decrease the resistance between the drain and the source, and hence more current is going to be able to flow between your drain and the source. But here's a feature that you need to be aware of. So at a specific voltage, gate to source voltage, there's going to be a specific amount of current that can flow between your drain and source. There's going to be a maximum that you're able to flow through your gate, your drain and the source. So let's imagine that you had a gate to source voltage of 3.5 volts. So here's what would happen. If I continue to increase my drain to source voltage, then the current is also going to increase proportionally. This is because here at 3.5 volts, I have a specific resistance, which is a constant, and hence if I increase my drain to source voltage, then my current is also going to increase proportionally in order to maintain this resistance. Remember, resistance is equal to voltage divided by your current. So if I increase my voltage there, then my drain to source current is also going to increase. But this will happen only until a certain region. So that region during which your current is going to increase proportionally to your voltage is called the ohmic region. But at this specific gate to source voltage, there is a point beyond which if you continue to increase your voltage, then your current is not going to be able to go beyond that level. So you start to see your current flattening out in the graph. You can look to that graph to my right. So at that stage, that's called the pinch off point. And if you continue to increase your source to drain voltage, then the current is not going to increase proportionally. It's going to remain constant at that level. So what you have to do at this stage is to increase your gate to source voltage. In other words, you're going to have to open your gate a little bit more in order to allow more current to flow through. So this is easy. You can simply increase your gate to source voltage to another threshold, which will allow you to flow more current between your source and your drain. So you can check with that graph. So at 4 volts, we also have a cap to the current that you can allow to pass through your source and drain. At 4.5, we also have another cap. So this information is important for you to look at in your data sheet. In case there's a specific amount of current that you'd like to flow through your transistor, you have to know the gate source voltage that you have to reach in order to allow that kind of current to pass through. So it's important to check your data sheets. Okay, we also looked at the N-channel enhancement, where we said that a channel is created which allows, when you introduce a positive gate voltage there, you're going to create a channel. In other words, it's an extension of your N-type material that then allows your current to flow from the source to the drain, or between the source and the drain. Okay, let's look at something else here. Let's look at something else. So that's the N channel that we're talking about. That's created when you introduce a gate to source voltage to allow your current to flow. So that's the switching that your transistor will do for you. So there's another type of transistor that we need to look at. So this one is called the N-channel depletion transistor. N-channel depletion. So with the N-channel depletion, there's already a channel created inside the transistor. So if you introduce a source to drain voltage, drain to source voltage, it's going to flow. In other words, your transistor is always on. It's like a closed switch. So what happens when you introduce a gate to source voltage, a negative voltage in this case, is that you are going to switch off the transistor. So you switch it off because here what happens is that the charges are going to be attracted towards the negative charge on the gate there, and in doing so your N channel will start to narrow, as you can see there in the animation. So it will start to narrow. The more voltage you introduce, the more your N channel will narrow, and eventually it will close off such that no current will flow. So you can introduce a gate source voltage that switches off the drain to source voltage. So this one you can use it to switch off the gate voltage is used to switch off rather than switch on, as we did in the N channel enhancement MOSFET. So those are some of the things to check out, the type of transistor that you're using and what places where it's suitable to use. Okay, so there's a resistance that you need to be aware of that's always there between your drain and source. So you need to check out that. How does the resistance change as I increase my voltage, my gate source voltage? Okay, so what else do you need to know? Okay, there's also a capacitance that's there between your gate and source. It's important for you to know this because so let's go back to the N-channel enhancement MOSFET. So you can remove the gate source voltage, and you might be surprised to see that the source drain remains switched on. So this is because there's a charge that's still there between your gate and source that allows the current to flow. So you need to think of ways to discharge this voltage potential difference so that you switch off the drain source voltage. So it's important to acknowledge that you may remove your gate source voltage and be surprised to see that your transistor remains on. So this is because there's a capacitance between your gate and source, and this capacitance is given in your data sheet. You need to be aware of it. So in your circuit design, you need to you may need to think of ways to switch off or to discharge that capacitance that exists naturally between your gate and source. So in other videos, we'll look at how this capacitance can be dealt with, how you can design circuits that are not disturbed by this capacitance. We'll also look at inductance that's there between these pins. So you might want to hang on for more information in this series. So I'll meet you in the next video where we'll look at circuit designs and what you can do with these MOSFET transistors.